In this lesson, we are going to learn two important functions: the rep, which stands for replicate, and the sample function. Now, let's imagine we are aquaculturists and we are rearing 5 types of fish. The first one is the mackerel. We also have the catfish, the tilapia, cod, and salmon. Now, these are the 5 fish which we have in our pond. Of course, if we want to take measurement of the fishes in our pond, we definitely know they are not 5, but we do know that there are 5 types. In such a situation, it would be unwise to keep repeating each fish name, mackerel, for like, let's say 50 times or 100 times. The smart thing to do is to use the rep function, which stands for replicate. The rep function takes 2 arguments. The first one is the name of the vector that you want to replicate. In this case, it's the fish type. The next argument is the number of times you want to repeat it. Let's say we want to repeat this 10 times. And here we go. Broiler, mackerel, catfish, repeated 10 times. What this function takes is just the argument, of course, x, takes the vector. Then we have times, which takes the number of times I want to repeat each element. There is another interesting argument, and that's each. Fish type 10 times equals 10. Now we say we want to repeat each of the fish type 3 times. And what this does is it repeats mackerel twice, catfish twice, tilapia fish twice. Then after it's done with that repetition, it iterates 10 times. As we see, we have mackerel, catfish, tilapia multiple times, then it starts again. So that's the power of using replication, and this can be a very useful tool in your arsenal. Next in our toolbox is the sample function. And what the sample function does is it picks elements randomly from a given object. For example, this type, which is having 5 elements, we can check that with the length. Fish type, that's 5. So we can pick one at random. That's tilapia. And if you want to check the argument of sample, once you write out the function, just press the tab button on your keyboard and you see x, which is the object name, in this case fish type. Then next we have the size, which implies how many do you want to return, like we did before. And if we run that now, see salmon. If we keep running this, see it's different. Next is replace, and this is where this function is very powerful. Remember when we simulated the die using RUnif? That is the wrong way to simulate such objects. The best way to simulate such objects is to use the sample. Now we are going to take this sample with die 1 to 6, having 6 size. So we have it die 1 to 6. So pass die into sample die, and we want to return 1, meaning we want to return just the results after we roll the die. Then we have this. Running this, we have 3. Running it again, we have 1. So this will continually produce results. Now the next thing we can do is we can roll the dice twice. And to roll the die twice, what we do is we increase the size to 2. And increasing it to 2 will give us 2 and 5. Here we have 1 and 4. And what we are doing here is rolling just a single die 2 times. To roll 2 dice at once, what we need to do is to use the next argument, the replace argument, and it takes a boolean value. We set that as true, so this can be true. Setting it to true, we ensure that each element in die here, that's 1, 2, 3, 4, 5, 6, have been replaced. That's probability with replacement, meaning once an element or object has been picked, it's having equal chance of being picked again. So what we have here is 63. Once we run it, I'm going to keep running this until we have double. Like here, we have 3, 3. If we remove replace, if we change it to false, it will never give us 2 numbers that are the same. So setting this to true ensures a number gets picked twice. Now, what we have here is a fair die. I mean, the casino grade die, the really engineered die that indeed every side are almost equal and the chances of getting any number is equal. But there are situations where the chances of any particular object or die being chosen is not equal for die that are not fair, we can simulate that. And to simulate that, we use the prob argument, which stands for probability. And what probability does is it gives weight to each item. That's to 1, 2, 3, 4, 5, 6, to each element of the die. So I'm going to put that here, and this is the probability that I came up with. The idea here is the probability should always sum up to 1. Once we run this, the probability of getting a number such as 6, especially appearing twice, it reduces. And that's because the probability of it occurring is slim compared to 1, 2, 3, 4 also. So if we keep running this, we have this. These are two very important functions that can also help your workflow.